Hey, it's Mr. Fisher with your Algebra 2 virtual lesson, and I want to jump right into it because you can pause and rewind, do all that stuff. We're going to work with this and delta math, an assignment for you. I wanted you to see this. You can, on this basic equation, I mean, you can simply solve this, right? Subtract 6 from both sides and find out that x equals 4. Bad handwriting, sorry. You can do that and get right to the answer. Boom. Nobody's having a problem with that. I want you to notice that you also can, now I'm not saying to do this, but I'm saying you can multiply this side by 10 as long as you multiply the other side by 10. Now what's that going to do? Well, I don't know, you might be confused on why I did that, but just follow through with me for a second. I multiply this side by 10, I got to do a little distributor property, that is 10x plus 60. I'll multiply this side by 10 because there's a little rule in algebra that says if you do something to one side, you must do the same thing to the other side. So 10 times 10 over here is 100. That's a true statement. Did it help me to solve it? Absolutely not. Did it make it more complicated? I would say, because the numbers are all of a sudden bigger. Is it still a true statement? Yes, it is, because I did the same thing to both sides. I'm going to go ahead and solve this just to kind of prove it. So I get 10x equals 40, and then I'm going to divide both sides by 10, and I get x equals 4 again. But there was no point in doing that. I could multiply this side by 25, and I could and then I'd have to multiply the other side by 25. 25 times this side, I have to do a little distributive property, that's 25x, plus 6 times 25 is 150, that's 6 quarters is $1.50. And 25 times 10, that is 250, just move the decimal. Now, okay, I did that. I made it a lot more complicated than just even multiplying it by 10. So I'm not sure it serves any purpose, but you could do it. Then I'm going to go ahead and solve it. 25x equals, it looks like 100. I divide by 25. How many quarters are in a dollar? There are 4 of them, so 100 divided by 25 is 4. It's the same thing. So obviously you can do those things, but my point here is, why would you? Okay, now I'm here to kind of share with you where we want to go from that. All right. Hold on a second. A little technical glitch here. Okay, so you can, well, all of a sudden it just got ramped up. Had a nice little simple equation. Now I got a very complicated one. It's got fractions in it. Fractions all throughout it. You could try to solve this. You could multiply everything by 10 over here. Is that going to simplify it? I don't know. I'm glad to have like 10x over 7 plus 10 times 5 or 50 over 21 equals 10 times 5 is 50 over 7. You can do that, but it just got nastier. You could multiply everything by 25 over here as long as you do the other side by 25. Well, you know the drill. It's just, you can do it. But which one helps you solve for x? Well, honestly, I don't think any of those do. So this is where we're going with this. All right, so bear with me for a second while I detour just a little bit. I noticed that the denominators were 7 and 21 and then 7 over here. Well, I want to get what we call the least common multiple. All right, LCM. It's not the least, the greatest common factor. It's a least common multiple. And what I mean by that is, if you look at the multiples of 7, 7 times 1 is 7, 7 times 2 is 14. These are multiples of 7. 28, 35. You remember the good old days when you got to do simple math like that, right? Just adding 7 each time or multiplying by 7. Multiples of 21. This could get a little bit more complicated. Whoops, I messed up right off the bat. 21, 42, 63, 84, and so forth. Okay, but the lowest common multiple of these two, see, these are all the multiples of 7. These are all the multiples of 21. What's the lowest number in each of the two lists where they match? Well, 21 and 21 is on both lists, and that's the, wait a minute, 42 and 42 also matches, and I'm sure if we continued those lists we'd find some other ones. But what is the, not the greatest, but the lowest common multiple? Well, it's 21. Okay, so I want to go back to, I think I do, I don't want to do that. I don't want to do that. Okay, I want to, whoa, I didn't mean to do that. All right, I want to use this lowest common multiple here that we got, and I'm going to multiply both sides by 21. So I'm going to multiply this whole side by 21 and this side by 21, and let's see what that does. So I picked this least common multiple, and I'm now going to multiply both sides by that. That's a strategic number. Before I said you could multiply by 10, but why would you? You could multiply everything by 25, but why would you? Okay, well, I'm going to show you why would you on this. All right, so that first thing I'm going to do is a little distributive property. That's 21 times x over 7. Come on. 21 times x over 7. I'm doing a little distributive property on this. Boop, and boop. And then plus 21 times 5 over 21 equals, well, 21 times 5 over 7. So I just kind of rewrote it with the 21 next to everything. Well, what is, let me change colors. What is 21 times x over 7? Well, first, I'm kind of hoping that you see that this 21 and the 7, that they reduce. 7 goes into that once, 7 goes into this 3 times. So this turns out to be just 3x, 3 times x, not 21 times x and then divided by 7. You can think of it that way, but it's 3x. Plus, well, look at this. 21 divided by 21, they just cancel each other out, so I'm left with 5. And then over here, 21 and 7, again, reduced to, well, 7 goes into that 3 times and 7 goes into that 1, so it reduces to 3 over 1. 3 times 5 is 15. So we just strategically multiplied everything by 21 and it got rid of the fractions. Is that a little bit mind-blowing or what? Because once I got rid of the fractions, aren't we like a 7th grade type of equation? I'm just going to subtract 5 from both sides. I got the 3x equals 10, and I'm dividing by 3. Now I ended up with a fraction, but that's at the very end. That's the answer to my question. That's not too bad. I'm a little bit concerned, like, oh, is it right? Because everybody loves to get whole numbers and positive whole numbers and that kind of thing. But it is the right answer, and I could plug it back in. I don't really want to waste your time with that right now. Maybe if we're in class, I'd have it all set up on the calculator and we do it. But that is why we chose to multiply everything by something. So this least common multiple, I really want to emphasize that. This least common multiple is a really important concept here. So let's take a break, and I want you to go to Delta Math, and I want you to pull up 4A.6, Basic Rational Equations. And I want you to, this first problem on here is called least common multiple. And when you do that, that is going to pull up, let's see if I can pull that up, least common multiple. It's going to pull up this little timer thing, and I'm going to hit start and just show you what it says. And see the timer, oh, it's making me nervous already. Don't worry about it. I want you to look at this question, find the least common multiple of 6 and 3, all right? And you might look at the numbers that are listed here. Do both 6 and 3 go into 6? Yes, they do. Do they both go into 18? Yes, but which one is the lowest? 6, obviously. Do they both go into 9? No, 6 doesn't go into it, so it's not, 9 is not a common multiple, so 6 in this case. Now find the least common multiple of 3 and 8. Well, 3 is, and I know that timer's bugging me too, so 3 and 8, so I'm popping back over, come on, popping back over here and getting a of 3 and 8. Well, 3, the 3, 6, 9, 12, 15, 21, 24, 27, 30. Hopefully it'll be in this list. 33, 36. Ugh. Okay, 8. 8, 16. Didn't see 16 up there. 24. Oh, there it is. So 24 is my lowest common multiple. Let's see if my timer ran out. It did not. So 24 is the lowest common multiple. All right. Least common multiple of 7 and 14. Well, that's 14 because 7 goes into 14 and 14 goes into that. Least common multiple of 8 and 3, I already did that one. It was 24, so I got a freebie. 14 and 2, well, it's 14. And I'm going to stop. This thing's making me nervous. All right, go try that. I just want you to get some experience, and don't worry about how many you get. Just get some. And if you get a few wrong, that's okay. It'll tell you your score over here. If you're super fast with it, before you get to 100 seconds, if you've done 10, you can stop or you can keep going. It'll show your best time for the meeting the 10. So give that a shot and pause this, and then come back to this as soon as you're done with that. All right. All right, assuming you did that, and now you're back to where I am. We're going to continue with this delta math, and you've gotten some work with this least common multiple. Let's just go through these first three problems together. Don't worry about hop on the bus, Gus. I'm not going to sing to you. There is a song that goes along with that, but I just want you to get on the program and do this with me. Okay, so the speed drill is over, but what is your answer to this question? You probably saw this. What's the least common multiple of 4 and 20? Well, 4, 8, 12, 16, 20. Ooh, 20's in there. 20, well, 20. Ooh, okay, so it's 20, right? 40 is a common multiple. 80 is a common multiple. 8 is not a common multiple. This is the lowest common multiple, and that's what we're kind of interested in. Okay, some teachers call this method fraction busters. All right, so this is a common thing that I'm about to show you. In fact, I kind of did show you actually. But let's take that last example of common multiple between 4 and 20. Well, remember, I could multiply every term by 10. I could multiply every term by 25, but that didn't help us. But now that we kind of know, there's something about this least common multiple, and when I say that the least common multiple between 4 and 20 is, well, 8, 12, 16, 20, whoop, there's 20, and 20. So it's 20, so I'm going to load it up right in front of each one of these fractions with a little times dot. All right, and by putting that there, now some people are going to say, okay, multiply that out. 20 times 3 is 60 over 4, but don't do that. Do this first. First, reduce it. It will always reduce if you choose the right lowest common multiple. 4 goes into 4 one time, so that's done. 4 goes into this 5 times, so all I'm left with is 5 times 3, or 15. 20 and 20 reduce. They cancel each other out. Sorry. And so I'm left with 7x. See, I didn't even have to multiply anything. I just had to reduce it. 20 over 4, well, again, that reduces to 5 over 1. The 1 doesn't matter anymore. It's 5 times 10 on the top. It's 50. All right, and now I'm going to solve it. So minus 15, minus 15. Hope you haven't forgotten how to solve these basic equations with all that extra time you had off. I'm left with 7x equals 35. I'm going to divide by 7. I get x equals 5. Now that's a feel-good answer, a whole number that's positive, and if I were to plug it back in, it would prove to be true. Okay, so I think that's the first one on your delta math that you have to do. How could you answer this one? I could multiply everything by 10. Well, we already said that, but would it help me? No, I wanted that least common multiple. All right, pause it and give it a shot on delta math. I'm going to pop over there to delta math and see what you guys are doing. That first problem. All right, it's been acting goofy today. Okay, it is that exact question, but instead of you giving me an answer, I'm asking you to use some of this logic over here. What do I do to each term with the least common multiple so that I can do what? Get rid of the fraction. Okay, so little thinking questions there. Yeah, I'm having a little delta math problem today. Come on. Okay, well, I'm going to go back to this. I think this is the next problem. Eventually, it leads into this. Okay, speed drill is over, but what's your answer to this question? Now, I modified it a little bit. What's the least common multiple between 4 and x? What do you mean, Fisher, 4 and x? Well, you know, when it was 4 and 20, we had the luxury of listing them out. 4, 8, 12, and so forth. Well, when it's x down here, it's an unknown. Well, here's what we're going to do is when it's an unknown, we're just going to multiply this and this, because whatever x is, if you multiply it by 4, you'll have a multiple of 4. So 4x is going to be my least common multiple. And I know you're going, what? Okay, so now that we're going to start throwing some variables into these denominators, I'm going to look over here. I've got a 4 here, I've got an x here, and I've got a 4x there. So you're kind of looking for the term that would have all of those denominators covered. And what I mean by that is if I multiply this by 4x over here, you'll see me load these up in the front. I'll put parentheses around them sometimes. I'm just trying to show that it's that multiplied by those. So 4x